Today, we'll explore RFID in detail, covering its foundations, functionality, applications, security features, and the exciting innovations shaping its future. Let me start by giving you an overview of today's agenda. By the end of this session, you'll have a clear understanding of how RFID works, its applications, and the technologies that secure it. Let's begin by defining RFID technology. What is RFID technology? RFID stands for Radio Frequency Identification, a technology that uses electromagnetic fields to automatically identify and track tags or cards attached to objects. An RFID system consists of three key components. RFID tag or transponder. This is where the data is stored and transmitted. RFID reader, the device that captures and processes data from the tag. Back-end system. This stores and analyzes the collected information, enabling actions based on the data. RFID is used extensively in industries ranging from retail and logistics to healthcare and security. But how does it work? Let's take a closer look. How RFID works. The operation of an RFID system can be broken down into a 5-step process. The reader emits a radio signal. The RFID reader generates an electromagnetic signal that creates a field around its antenna. This signal is used to detect RFID tags and enable communication. The RFID tag receives the signal. For passive tags, these tags have no internal power source and rely on the reader's signal to activate their circuits. For active tags, these have their own power source, such as a battery, and can communicate independently. The tag sends data back to the reader. Once activated, the tag transmits its data, typically a unique identifier, back to the reader using radio waves. Passive tags use backscatter modulation, while active tags send stronger signals. The reader processes the data. The reader decodes the tag's data and forwards it to the back-end system. The back-end system takes action. The back-end system processes the data and performs specific actions, such as granting access, logging attendance, or tracking inventory. RFID systems operate on different frequencies, which determine their range and applications. Types of RFID systems. There are 4 primary types of RFID systems, categorized by their operating frequencies. Low frequency LF, operating between 125 and 134 kHz. LF RFID systems are commonly used for animal tracking and access control. High frequency HF, operating at 13.56 MHz. HF systems are ideal for contactless payments, NFC, and ID cards. Ultra-high frequency UHF, operating between 860 and 960 MHz. UHF RFID systems are used for inventory tracking, vehicle identification, and other applications requiring longer read ranges. Now that we understand how RFID works, let's discuss the 2 main types of RFID tags: passive and active. Passive RFID tags. Passive RFID tags are the simplest and most commonly used tags. Definition: these tags do not have an internal power source. Instead, they rely on the electromagnetic energy emitted by the RFID reader to activate their circuits and transmit data. Let's now look at active RFID tags and how they differ. Active RFID tags. Active RFID tags are more advanced and powerful than passive tags. Definition: these tags have an internal battery that powers their circuits and antenna. Comparing passive and active RFID. To summarize, here's a quick comparison between passive and active RFID tags. RFID authentication methods. Authentication is critical for ensuring the security of RFID systems. There are 2 main types. One-way authentication. The reader authenticates the tag by sending a challenge and validating the tag's response. Use cases: moderate security applications like inventory tracking. Limitations: vulnerable to replay attacks and unauthorized readers. Mutual authentication. Both the reader and the tag authenticate each other using cryptographic protocols. Use cases: high security applications like contactless payments and secure access control. Advantages: protects against rogue readers, replay attacks, and man-in-the-middle attacks. RFID versus NFC. Many people confuse RFID with NFC. While these technologies are related, they serve different purposes. NFC is a subset of HF RFID, designed for short-range, secure communication. It's widely used in mobile payments, contactless ticketing, and peer-to-peer file sharing. How RFID tags and cards are constructed. RFID tags and cards consist of three main components. Integrated circuit. IC. This is the brain of the tag, responsible for storing data and managing communication. Antenna. Facilitates the transmission and reception of electromagnetic signals. Substrate. Holds the IC and antenna together, providing physical support and protection. Optional features, such as batteries for active tags or tamper-resistant designs, enhance the functionality and security of RFID cards. RFID security. While RFID offers incredible advantages, security is a critical concern. Here's how RFID systems ensure data protection. 1. Encryption. Advanced algorithms like AES encrypt data during storage and transmission. 2. Authentication. Mutual authentication ensures both the reader and tag verify each other's legitimacy. 3. Key management. Secure access modules generate and store cryptographic keys. These measures protect RFID systems from threats such as cloning, skimming, and eavesdropping. RFID technology is transforming industries with its ability to provide real-time data and streamline operations. From inventory management to secure payments, RFID's applications are endless. With advancements in security and integration, the future of RFID looks bright. Thank you for your time and attention. I hope you found this session insightful.